Welcome to Lesson 1.5 Guided Notes. Today we're going to be converting between the forms of quadratic functions and doing some application practice. So key issue number 1. You can change quadratic functions from intercept form or vertex form to standard form by multiplying algebraic expressions. And what we need to remember, and that we practiced in IXL in our summer work, was multiplying binomials. All right, so these are the three forms that we've been working with. Standard form, vertex form, you can see the vertex right there in HK, and intercept form, you can see PQ, which are our roots or our x-intercepts. Now, sometimes we want to be in one form and we're in the other. So, for example, in this one, we're looking at something that is in intercept form and we would like it to be in standard form. All right, so let's try practicing converting from intercept form to standard form. So the original function looks like this. So we're going to work on this sample first. We've got two binomials, and we want to multiply them together to put our equation into this form. So the first thing we're going to do is multiply x times x, and we get x squared. X times negative 9 is negative 9x. And now we're distributing again. Positive 4 times x is a positive 4x. And a positive 4 times a negative 9 is negative 36. The next step we're going to do is combine like terms. So we're combining these two terms here. We have negative 9x plus 4x. And if we combine those, we get negative 5x. All right, so we bring down our minus sign. We bring down our parenthesis, bring down x squared, and we have minus 5x minus 36. And the last step is to distribute that sign that's sitting out front. So if we have a negative sign here, that means what it's actually asking you to do is give me the opposite of everything that's inside that parenthesis. So I have a positive x squared, the opposite of that is negative. I have a negative 5x, the opposite of that is a positive. And I have a negative 36, and the opposite of that is positive. So now this is in standard form. We can see that the a is negative 1, the b is 5, and the c is 36. Okay, so we're going to do one over here together using the same steps. So first thing we want to do is bring down what's out front. We're not going to do anything with that minus 2 first. And now we're going to multiply the binomial. So the way we do that is we distribute. X goes to x, and I get x squared. X goes to negative 8, and I get negative 8x. Now I'm going to distribute the negative 5. Negative 5 to x is negative 5x. And negative 5 to negative 8 is a positive 40. Okay, so now I need to distribute the negative 2 that's out front. Oh, sorry. Let's do one more step. Let's combine like terms. We have x squared, and I have a negative 8x and a negative 5x. And if I combine those two, I get negative 13x. Sorry about that. All right, now let's distribute that 2. Negative 2 times x is negative 2x squared. Negative 2 times negative 13 is a positive 26x. A negative 2 times a 40 is negative 80. We're now in standard form. Okay, we want to use the exact same idea to convert from vertex form to standard form. And remember, vertex form is minus h plus k. And we want it to look like this. All right, so let's start with, here's my vertex form, and I want it to look like what's down here. So the first step I'm going to do is I'm going to rewrite this. So this is saying negative x plus 2 squared. So we're going to write it as x plus 2 times x plus 2. And I left some space here so that we can do this. We'll do y is equal to, I'm going to leave the 5 alone, it just stays put. And now I'm going to distribute. X times x is x squared. X times 2 is positive 2x. Now I'm doing 2 times x is positive 2x. And 2 times 2 is 4. And we still have our minus 9. Okay, so now I'm going to combine these like terms in the middle. So I'm bringing down the 5. I bring down the x squared. A 2x plus a 2x is 4x. I still have my plus 4 minus 9. Okay, order of operations says that we need to multiply first. So we're going to multiply this 5 to everything inside here. So 5 times x is 5x, and 5 times 4 is 20x, and 5 times 4 is 20x, and I still have my minus 9. And this is when I'm just going to do that final step, where I'm going to do 20 minus 9 is 11. So I'm going to bring down all of this, and now I have my standard form. So it's the same idea before. The only difference is you have to realize that you're multiplying the same binomial. So let's go over here and try the same thing over here. So I'm going to do y is equal to, I'm going to bring down my 9 as 3. And now I'm going to rewrite this as x minus 4 times x minus 4, because we're saying x minus 4 squared plus 7. All right, I'm going to bring down my minus 3. And if I square this, x times x is x squared. X times minus 4 is minus 4x. Minus 4 times x is minus 4x. And minus 4 times a minus 4 is a positive 16. And I still have plus 7. Whoops, let's move that over. There you go. All right, so now let's combine some like terms inside here. I get negative 3 x squared minus 8x when I combine those two, plus 16 plus 7. Y is equal to, I'm going to now distribute this negative 3 all the way through. So I have negative 3 times x squared, which is negative 3x squared. A negative times a negative is a positive, and 3 times 8x is 24x. A negative times a positive is a negative. 3 times 16 is 48, plus 7. And now the last step is combine those two. So now I have y is equal to negative 3x squared plus 24x minus 41. Okay, so what we just did was we practiced a skill. And you're going to practice that skill on your lesson 1.5 practice sheet. The next thing I want to do is talk about real life situations. So how do we apply quadratic equations to real life situations? Example 1, using a quadratic model in standard form. So the next few are all just going to be standard form. Researchers conducted an experiment to determine temperatures at which people feel comfortable. The percent Y of test subjects who felt comfortable at temperatures X in degrees Fahrenheit can be modeled by this equation. So I always pull out my highlighter and highlight if I can find what's Y and what's X, so I can visualize in my head what's going on. So they just said that the percent of test subjects, so I'm looking for a percentage for my Y value, and a temperature in Fahrenheit is for my X value. So their question is, what temperature made the greatest percent? So they want to know when Y is at its biggest, what's my X value? And then answer the question, at what temperature did that occur? Okay, so we're looking for the highest value. So you can visualize in your head that you're looking for that maximum value right here. So that maximum value is also your vertex. So we're looking for the vertex, and this is in a standard form. So if it's in standard form, you're immediately going to start writing down A, B, and C. And what's different about this is that numbers don't always look pretty. So for A, it's negative 3.678. For B, we have 527.3. And for C, we have negative 18.807. All right, so I want to find when Y is at a maximum. So I'm looking for my X value first. So X is equal to minus B over 2A. X is equal to minus 527.3 over 2. And A is negative 3.678. Okay, so I'm going to stop and go get my calculator and calculate that. Okay, so I went and got my calculator and I typed in negative. Whoops, let's see this. Negative 527.3 divided by. And now I want you to notice what I did here. When I divided by, I needed to divide it by 2 times whatever this is. Now, if I key it in like this and put parentheses around here, it's going to give me this for a value. Watch what happens if I don't. So what if I do negative 527.3 divided by, And now I'm just going to do 2 times negative 3.67 equals. I get 967 for an answer. The difference is our calculator is really smart. What's happening here is it's saying take this number and divide it by 2 times this, the quantity 2 times this. If I do it this way, it says negative 527 divided by 2, so I'm only dividing by 2, and then whatever my answer is, I'm going to multiply that entire answer by negative 3.67. Okay, so I need to always put this inside parentheses, all right? All right, so then this is a value for, what am I looking for? X. And what's my X value? My X value is temperature. So it's 71.68297 degrees Fahrenheit. So let's round it to the nearest whole number and say 71, and then look at the number next to it, and we're going to round up to approximately 72. So we're going to say that our value is approximately 72 degrees Fahrenheit. So this X value up here is 72. Okay, if the X value is 72, then we're going to put that value back in and find the matching Y value. So let's do that. So we're going to do Y is equal to negative 3.678, 72 squared, plus 527.3 times 72 minus 18807. And again, I'm coming back over here, and I'm going to use my calculator. So give me a minute to put that back in. Okay, so now I've approximated here by putting in 72, and this is what my answer is. So again, I'm going to round to the nearest whole number. So if this is 91, I'm going to round that up to a 92. I want you to practice using the graphing calculator and see if you get the same answer that I got, because I want you to be really comfortable with this. All right, so this is a percentage. How do I know it's a percentage? Because it tells up here that is a percentage of test subjects. So this is 72 and this is 92. So the 72 Fahrenheit, 92% of the people were comfortable. This next one is actually a little bit easier because it's in vertex form. So it said a ball football field appears to be flat. Its surface is actually shaped like a parabola so that the rain runs off to either side. The cross-section of a field with a synthetic turf can be modeled by this picture, where X and Y are measured in feet. What's the field's width and what's the maximum height? Okay, so they're telling you this is an actual picture of the field. So the field, if I started here and went here, this would be the width of the field. And then this would be the height of the field. All right, so then what are we looking for? If I want to know what the height is, I'm looking for the Y value, the height of the field. And if I want to know what the width is, I want to know what that X value is. Okay, so let's start off with this value right here. All right, so what's that value? Well, we come here and we look at Y is equal to A, X minus H squared plus K. So what's my H value? My H value is 80. What's my K value? It's 1.5. So that means this position right here is at a height of 1.5, and it says it's in feet. So the height is 1.5 feet. And we get that just from looking at that vertex. Okay, now what does that 80 help us with? Well, remember, this is the line of symmetry, correct? So from here to here, it's a distance of 80 feet. So then what's the distance from here to here? It would be another 80 feet. So 80 plus 80 is 160. So what's the width of the field? 160 feet. And we get that just from finding out what the X value is for the vertex. All right, so you're going to practice doing some application problems, and you're going to practice doing some converting problems. And please feel free to ask any questions in class today. Have a great day. See you later.